In this video, we're going to look over some questions which are part of a homework on forecasting. The first question asks us to use exponential smoothing with a smoothing constant of 0.2 for a data set in Excel. So here's the data set that we can open by downloading this file, and let's develop our forecast. So we need one piece of information to do exponential forecasting, which is the smoothing constant called alpha. The question tells us that is 0.2. Sometimes the question will give us an initial forecast, like in this case, it says the forecast for the month of May was 105. Okay. This is the second piece of information we need, and then we can develop our exponential smoothing forecast. We need to develop the forecast for this next month of January. So we have to figure out what goes in this cell. Okay. If we were not given an initializing forecast, a forecast for some time period, then we just take the first row of data we have and we set that forecast equal to a naive forecast. We assume the forecast for this month is the same as the demand for this month. So it's not a naive forecast, because naive forecast would be you put 100 here. The forecast for June is the same as demand in May. That'll be a naive forecast. We just initialize that at 100. And actually that will make this forecast become 100 as well. And then you will get different forecasts going forward. Okay. And so you just initialize the first row, the forecast, to be the same as the demand in that row. This is not a true forecast, it's just an initialization value, and then you can build your exponential smoothing forecast. We do this as a default if we are not given the forecast for a particular month. Remember, the forecast for a month is not the same as the demand in general. And so the forecast for May, the 105, was computing probably using past data we don't have. Okay, so however this forecast was computed, whether it was done with exponential smoothing or not does not matter. It just initializes the algorithm, which is the recursive, to be able to start at a certain forecast value. And as you go down, the initial value matters less and less. Whether it's 105 or 100, it's not gonna matter too much by the time you get here. Okay, so let's start building our forecast. If you look at the slides, we can see the formula for exponential smoothing. And the formula is given in two forms or two equations. You can use this formula, and if you do a rearranging of the algebraic terms, you get this formula. Okay. You can use whichever one you want. Basically, it's alpha times the previous time period's demand plus 1 minus alpha times the previous time period's forecast. Okay, so we'll do alpha. Okay, and you want to add $sign, so when you drag the formula down, it does not move the 0.2 around, times the previous time period's demand plus 1 minus alpha times the previous time period's forecast. Oh, I made a mistake in my equation. I put a symbol called and instead of asterisk for multiplication. Okay, now we can drag the formula down by dragging this corner. And we get the forecast for January to be 111.46. Okay, we will check the question for how many decimal places we want. 2 decimal places. So it'll become 111.47 to 2 decimal places. Okay, so exponential smoothing is relatively easy. You're given the smoothing constant. You're either given a starting value, or if you're not given, you set the starting value equal to the demand in the first time period. Now imagine if you're not given 105 and we just put in 100. Notice that the forecast is not changed much, 111 versus 110. The further you go in the future, the less the initialization value matters. And so we will use 105 just to get the exact answer we need. But if you are not given this value, just set it equal to the demand of that month. Okay, calculate the forecast error for June to December months. What is the MAD, mean absolute deviation? Notice it's telling us to calculate the error for these months. Why don't we calculate the error for May? Because the 105 is, we don't know if it was done using exponential smoothing. How did this forecast come about? It's just an initialization value in a sense. And so we don't need to calculate the error for the initialization value. So we only need to calculate the forecast error over this time period. So the forecast error is always the actual value minus the forecast. It could be positive or negative. Okay. You don't want to calculate the error here because we don't know the demand for January, so we don't calculate the error for this month because we don't have the actual demand. Now, we do want to take the absolute value of the error so we don't get negative values. So that's called the absolute error, or it can also be called the absolute deviation, AD. It's the ABS function in Excel. ABS of this value will take away the sign, leave only positive values. Okay. Once we do that, the average value of these absolute deviations is MAD. Okay, so this is our MAD value. Okay, so what is the MAD to 2 decimal places? That's 12.19. If you calculate the average without taking the absolute value here, you'll get a smaller number, and that will not be accurate because the negative error cancels out the positive errors. But you don't want that because this is an error, this is an error. You don't want to cancel them out because they're both errors, although in different directions. So we don't care about which direction the error is, we care about the magnitude of the error. So we take the absolute value, get all the absolute errors for these months, and then we take the average of these values to get the MAD. To calculate the MAP, once you have the absolute error, things get easy. So we need the percentage absolute error, which is just you take the absolute error divided by the value of the demand. Okay. And so that tells you that this 24 is 30% of the demand. So you are off by 30%. Then you can, 30% is represented as 0.3. Then you could calculate this for all of these months, right? These are all percentage error. And then you can calculate the average of these percentage errors, where you have calculated the percentage by dividing the absolute error by the actual demand. So we calculate the average of these percentage errors, and that will be MAP. Now, usually you have to do one more step. You want to multiply it by 100 to get it on a percentage scale. So, 0.17 something, 0.118 is going to be 11.8%. Okay. And so you want to put this in as MAP. Okay, so it does say that enter on a scale of 0 to 100. So you do have to multiply by 100. Otherwise, this is on a scale of 0 to 1, where 1 means 100%. So you have to multiply it by 100 to get on a 0 to 100 scale, which is this value. And we need the answer to 2 decimal places. So 11.76% is the answer. We're going to type in 11.76. We did not enter the percent sign according to the instructions. And that is it for the first question about exponential smoothing and calculating the MAD and the MAP. Okay, let's look at the next question. So we have a post office, and we have some data given in an Excel file. We expect there to be seasonality over days of the week. So we have to compute the seasonal factors, and what is the seasonal factor for a Monday? So let's look at this data. Okay, so we can see mail received in thousands, week 1, week 2, and we have the different values by day of the week, and we expect there to be seasonality over the days of the week. So to calculate the seasonality, we need the average daily demand or the average daily values. And so we have to take the average of week 1, and then we can just drag it to the right to get the average of week 2. So week 1 on average, the average day was 32,000 pieces. Week 2, the average day was 30,000 pieces. So now to calculate the seasonal factors, we have to figure out, usually what percentage of this average value is a Sunday. What percentage of this average value is a Monday, and so forth. Okay. So we can do it here. So we'll do week 1 seasonal factor, then we'll do week 2 seasonal factor. Okay, and the week 1 seasonal factor, you just take the week 1 value, divide by the average value for week 1. This is where a lot of students will make mistakes. And they'll calculate the average of both weeks together, which is 31, and then they will divide the 5 by 31. That is not correct. You only divide the values of week 1 by the average for week 1. And we want to put dollar signs, so when you drag the formula down, the 32 does not, this cell does not move down to get empty cells, it stays on 32. So we lock the red cell to 32. So this shows us a 0.15, so 15%. So Sunday is 15% of an average day. So it's slower, because if you're 100% of an average day, you are like an average day. If you're below 100%, you are slower than an average day. So Sundays are slower than the average day. They're only 15% of an average day. If you drag it down, we get the different values. And we can see that Mondays are also slower than the average day. Tuesday is basically an average day. It's about 1, which is 100%. Tuesday and Wednesday are both approximately an average day, just around 1. And then Thursday is much higher, and Friday is very high, twice the amount of volume than an average day. And then Saturday is again much slower. Do the same thing for week 2. Why? Because the seasonal factor, this is one estimate of the seasonal factors. We'll get a second estimate from week 2, and then we'll average the estimates out to get a more reliable estimate of the seasonal factors. So according to week 2, the seasonal factors look like this. You divide the daily demand by the average value. Okay, and notice that week 2 is saying a Sunday looks like 26% of an average day, whereas week 1 is saying a Sunday looks like 15% or 16% of an average day. They're both estimates, and they both can have errors, so we'll average across them to reduce the error. So we get the seasonal factors for week 2, and then we can get the average seasonal factors, which are just the average of your seasonal factors you've computed for each cycle. This is a cycle because after a week is over, seasonality pattern will repeat the next week. This is one cycle, this is the second cycle. So each cycle that you have in the data, you calculate your seasonal factors, then you average them to get a more reliable estimate of the seasonal factors. Okay, so you do want to check that the seasonal factors sum to how many observations you had. We had 7 observations in a cycle, so week 1 had 7. And if you look at the sum of these seasonal factors, it does sum to 7, so we are fine. If it did sum to something like 8, you would have to rescale it. So you would divide each of these by 8 and multiply by 7, so they would get rescaled to add up to 7. Okay. If we had quarters in a year, there were only 4 values in a cycle, they would add up to 4. If this was months in a year, there were 12 values in a cycle, then this would all add up to 12. We'd have 12 seasonal factors that will add up to 12. So we just want to make sure that is happening. It should happen by default, but if it doesn't, for some reason, you can rescale them by dividing by whatever their sum is and multiplying by 7 or 4 or 12, whatever the sum should be. So divide by the actual sum, multiply by what the sum should be, you rescale each value like that, and then they are fine. So they're already fine as is. We need the seasonal factor from Monday to 3 decimal places. That will be 0.563. Okay, don't use this because they are all estimates from one cycle of data. You want to average over the estimates from all the cycles in the data you have. We have 2 weeks, 2 cycles. So the average across the two will be average of this and this, which is 0.563. Okay. Now the manager expects a total of 23,000 pieces of mail next week. How many does he expect to receive on Friday? So in the next week, okay, we expect 230 pieces of mail. Why did I put 230 here and not 230,000? Because everything we're doing here is in the thousands. Well, actually, seasonal factors don't have a unit. So even if you put 230,000, that would apply. But just because if I put 230,000 here, somebody might say, well, how come your demand in week one, week two is so small? And here it's 230,000. This is 230 because everything is in thousands. So if the total of next week is 230,000, then what's the average one for next week? Well, the total over number of days, 230 over 7. That's my average for next week. So the average for next week is expected to be 32.8. If this is the average, you can multiply it by the seasonal factors to get the projected forecast for each day. Projected forecast. Okay. That will be our seasonal factor times what we expect the average day next week to look like. I put dollar signs to lock the red cell down. So when I drag it down, just the blue cell moves down and they all get multiplied by the same value here. Okay, so you can just drag it down. So this is our forecast for next week. We expect Sunday to have 6.9, about 7,000 pieces of mail, 18,000, and all of these are thousands. Remember, the units are mail received in thousands. So all of it is thousands. And it says, enter your answer in the nearest integer. How many pieces of mail are expected on Friday? So we look at Friday, and we expect 74,271. So we'll just multiply it by 1,000 to get the actual pieces of mail. So it's 74,270.83. To the nearest integer, it's going to be 74,271. Okay. Okay, now we are done with this seasonality question. So let's go on to our next question, which is a medical testing lab. Okay, so here we have walk-in arrivals for the data for the past 16 weeks is given. Let's look at the data. Okay, so we have time, which is a week number, and then we have the actual arrivals, which is our actual demand, and we can use the trend in over time to project the demand forward. Okay, so the first question says plot the data and see if there's a trend. So we're gonna plot this on the y-axis and time on the x-axis. So we go to insert. We want to do a scatter plot which is connected by lines. Okay, so just to double check, you can click this line, okay, and then you can actually right click it and go to select data and make sure that the x values are column A values and the y values are column B values. So y-axis has the data, x-axis has the time. Okay, so the way we got it was, we went to scatter plot. This is a scatter plot symbol, and you want to get a scatter plot connected by lines. So it's not just points. We can see the line trend if it is connected by lines. Okay, and so we can see that the average, the trend is an upward trend. We can see the values get larger and larger. So that's called a positive trend when you see growth. And when you see decline, like a line going down, we call it a negative trend. Why is it positive? Because the slope of a line going upwards is a positive slope, and the slope of a line going downwards is negative slope. So that's called a negative trend. So this will be a positive trend. Use regression to forecast the arrivals for week 17. So we have to forecast for week 17, okay, here, and we have to use regression. So we will, to use regression, we go to data, and data analysis. If you don't see data analysis button here, you go to tools and Excel add-ins on a Mac, and you enable the analysis toolpack. Select this and hit OK. And on Windows, you have to go to File, Options, and then Excel add-ins or add-ins, and then Excel add-ins, and then you select Analysis Toolpack. In any case, if you can't find the Data Analysis button here, in the Data tab, just Google how to enable Analysis Toolpack in Excel on Windows if you're on Windows, or on Mac if you're on Mac, and you will find a lot of tutorials online on how to enable it. I've kind of shown it to you for Mac. Go to Tools, Excel add-ins, and on Windows you go to File, Options, and then Add-ins and Excel add-ins. You hit the Go button and you just select the Analysis Toolpack. Okay. So once you have the Data Analysis button, you go there. You have the regressions. So initially you maybe had ANOVA. You may just scroll down to R, sorted in alphabetic order. So you go to regression, you hit OK. Your Y values are what you want to forecast. We eventually want to forecast the walk-in arrivals. So we select our Y data, including the label. Okay, I like to select including the label because it makes the Excel output easier to read. Our variables which predict our Y value is just one variable, time. We don't have any other predictors to predict the Y. If we did, they would be in a column next to it. We'll select the two columns together, right? So imagine the predictors were in column C and D. Then you would select two of them like this, or three of them like this, four of them like this. Select all those columns together, whatever your predictors are. But right now we have just one predictor, so we have to select just one column for X. Okay. I hit labels because I'm starting at row 4. You can see B4, A4, and the 4th row has my labels. So just tell it to, don't think the first value is a number, the first value is a label. That's all I'm telling Excel. Okay. And I can just put it somewhere down here, my output, and any empty space. Okay. And I hit OK. And it does the regression, gives me the output. You can see it's labeled as week, which is this column here. Why is this? It knows this is to call this week because I selected the labels. If you did not select the labels, you went here and did not check the labels button because you only had numbers, then it'll just say like variable 1 or x1. So it wouldn't give you like a label based on your data. Okay. Okay. So R-square value is important. If we have an R-square of 0.829, about 83%, that's a very good value. And this is my regression equation right here. So my prediction y hat equals 28.5, that's the intercept, plus 2.345588 multiplied by the week number, whatever week I'm on. So that is my regression equation given by these values right here. And I can use that to predict. So what is my prediction when my week number is 17? So I'll do that. I'll put in this formula. I'll take the intercept. And you want to put dollar signs. So you want to lock that cell in. And you don't want to move it around if you drag the formula. Plus the coefficient for the week. Okay, that's 2 point whatever times the week number, which is 17 right here. And so my forecast is 68.375 for week 17. Now it says rounded to the nearest integer. So 68.375, because it's less than 68.5, will round to 68. Okay. What is the R-square for the regression forecasting model? Do not type in the percentage sign. Enter your answer to 2 decimal places on a scale of 0 to 100. So Excel gives you the R-square, and actually I made a small mistake first. I actually read 83% or 82.9%. This is not R-square. This is multiple R. This is the correlation between the predicted values and the actual values. So ignore the multiple R. R-square is given right here, which is 0.688 or 68.8%. So you need to, it's on a 0 to 1 scale, so you multiply it by 100 to convert it to a 0 to 100 scale. And we need to 2 decimal places, so it's going to be 68.83, because the 9 makes this 4 become 5, the 5 makes this 4 become 5, and then the 2 5 rounds to 3. Or you can just go here and use this button to round it to 3 decimal places. Now Excel is actually running to 82, which is also correct, because 824 or 825 should round to 820 or 830. If I was running, I would just round it to 68.83. Either way, it should mark it correct because there's a tolerance built in. So in my view, this should round to 68.83, because the 4 here rounds to 5. The 5 makes this 4 5, and 825 rounds to 830. But if you want to do 68.82, that's also fine. So both of those answers are acceptable. To 2 decimal places. Okay, so that's our own. R squared goes here, 68.82. Okay, and here our arrivals were also 68. So wow, a nice surprise that this answer is very close to this answer. About 68.3 here, which is rounded to 68. It is 68.83 or 68.82. Okay, and we do not enter the percentage sign. Okay, what is the MAPE for the regression model? Compute over weeks 1 to 16. Okay, so we have to compute the MAPE for weeks 1 to 16. To compute any error statistics, we need to know the actual demand and the forecasted demand. So what's our forecast? And I'm going to move this to the forecasted column, because week 17, this is not the demand, this is actually the forecast, right? So first I have to calculate the forecast for weeks 1 to 16, and then I can compute the error, the absolute error, the percentage absolute error, and then the average of the percentage absolute error will give me my MAPE. So how do I get the forecast? I use my regression equation to get the forecast for all of these things. Okay, plus 2.345 times week number 1. And I put the dollar signs there to lock these two cells, the blue and the red cells. So when I press enter, I can just drag it down to get a forecast over weeks 1 and to 16. I can only compute error for weeks 1 to 16 because for week 17, I do not have the actual demand. I don't know the actual demand to be able to know what is my error in week 17. So error is always actual value minus the forecast. We can drag it down. The absolute error is just the absolute value of that number. I usually do it in one step. You can just do ABS here, B5 minus C5, but just to show you all the steps, I'm doing it in 2 steps. You can get the absolute value, that'll take out the negative values. Then to get percentage, you do this divided by the actual demand. So there was like a 10% error, 0.1 is 10%, so 0 to 1 scale. And we get this. And then you can take the average of these numbers to get your MAPE. And so the average error is 0.13. If you multiply this value by 100, you get on a 0 to 100 scale of 13.53. Okay, so we do need 2 decimal places. Do not enter the percent signs. We'll enter 13.53. 13.53% is the MAPE. Okay, and that is it for this homework. Hopefully this was helpful, and hopefully you understood how to do these problems.